I'd like to welcome Sugu from YouTube, who's going to talk to us about Vitess. Sugu tells me that you can think of Vitess as being similar to MechRouter for Memcached, but this is for MySQL. Vitess is for MySQL. So let's hear all about it. Cool.
Hi there. So this is last session for the day. So after this, we get to go party. So that's good. I have a small confession. I don't know exactly how long this talk is going to be. I think it'll be 45 minutes, so I'll try to finish around that time, but we may go a little bit over under. So so we'll go from there. So my name is Sugu, and I've been at YouTube since around 2006. For the last 4 years, I've been working on Vitess, which myself and our team is extremely excited about. And hopefully, by the time I'm done with this, I'm expecting all of you also to get excited about what we've done and how you can also get to use it. So just to go back, the gopher in the car means something. I don't know how many of you recognize what that means. Ah, there's one. One person, all right. Oh, there's two, three. OK, a handful. So the Vitess was written in Go, and our entire team loves Go as a language. So I do have one slide to talk about Go and what it did for us. So what is Vitess? Is basically a scalable storage solution. It's based off of MySQL. And it's mainly meant for online applications. And so if you're writing a web or mobile service, you will need a backend. And eventually, if your mobile service becomes even moderately popular, you have to figure out ways to scale it. And we at YouTube faced the same challenges. And we figured out ways to solve them, and Vitess being part of the solution. So I'm going to talk about how we went about doing that. And so it is now fully used at YouTube. And it is open source, which means that if you face problems similar to what we faced at YouTube, you can also benefit by using Vitess, most likely. So if you start off, if you build your first website, the first thing you do is bring up a database and then bring up some web servers and then start using it, and eventually open up your web servers, people start using it, and then the database starts filling up with data. And after a while, you realize, oh my God, there's interesting stuff in the database. I need to make sure that I don't lose it. So typically what you do is you take your web servers down to take backups every once in a while. And eventually, that obviously runs out of steam, so you need to go to the next phase. These are all like scaling 101, so I'm not spending too much time here. So the first thing you do is you set up a master and set up a couple of replicas. So as soon as you do that, you get a breath of fresh air. You get a huge durability improvement because there's 2 replicas keeping up with the master. And there's also a huge uptime improvement because now you don't need to take down the master to take backups. If a master fails, dies, you fail over to a new replica as a master, and then keep chugging along. And so this is the benefit that you get. And then you look at it and say, well, there's like 2 replicas sitting doing nothing. Might as well send some read traffic over there. So you get to distribute your load and scale that way. But of course, the moment you do that, you have to think about what you're giving up. As soon as you direct your reads to a replica, you are going to be reading stale data. And your app might or might not have been written to handle stale data, which means that you may have to go and refactor some of the things. The way we solved it at YouTube is we kind of categorized reads into 2 parts. One is obviously a replica read, which means that let's say you want to just show a video. You don't really care that the view count is completely up to date. Somebody wants to see a video, just give it to them. That's how our users are. So those reads always go to a replica. We just read whatever is there, display it, and we are done with it. But then there are some other use cases where people want up-to-date information. Like I go update my profile, and hit submit. And as soon as I hit submit, the first thing I do is I refresh and see if my information got updated. So we kind of identified those workflows and it says, oh, those things, we should send those reads back to the master. So we have actually 2 categories of reads, and the YouTube app is written to either go to the replica or go to the master, depending on how up-to-date your data has to be. So this is actually a good flexibility because this helps you kind of sidestep the CAP theorem. I think somebody else mentioned about it today, where you can only get consistency or availability and not both. In our case, we kind of get both, but we are basically playing with the laws of physics here. But it is, but it works. As you can see, like if you go update your profile and immediately hit refresh, you will see up-to-date data. We have made some trade-offs here. I'll talk about all the trade-offs we make as we scale, because those are trade-offs that you'll also be making when you scale your database. But this actually can take you for a while. And we survived this architecture at YouTube for a long time, until our write QPS started catching up to us, and our master, actually it's not our master that couldn't keep up with the write, it's actually the replication. So as soon as your write QPS exceeds certain amount, the replicas just cannot keep up. And as the previous speaker mentioned, it's because of the single-threadedness of the replication stream. So there is a one-time answer to that thing, which is called Prime Cache. It was actually written by my good friend Paul Tuckfield, who is not here today. He left, actually, to work at a social company. But he came up with this idea of Prime Cache. What he said was, this is single-threaded, and these threads are all disk-bound. So what he wrote a tool which would actually read this relay log and look at all the where clauses and preload those rows into the cache before the replication stream would come and replay them. So which means that all these I/O operations that used to be, all these replication operations that used to be disk-bound, now suddenly are memory-bound. We got a huge increase in our replication throughput, and we survived for a while with that. But then, after a while, that also ran out of steam. Your app may be different. You may not saturate on write QPS, but you're going to saturate on storage capacity. Eventually, your database is going to be so big that it's not going to fit in, on one disk. So when these things happen, you have to take the next step, which is obviously to break this database into multiple parts. So when you break a database, you break it up 2 ways. One is you break it vertically, which means that you identify a group of tables and say, oh, this is a logical database. Let me migrate it out into a separate database. Or you may shard it. I think we have heard sharding enough that I don't have to explain what it is. So you do both things when you scale a database. You do both things, and I'll talk about how Vitess supports these things. So actually, the first time the person who did this is actually in this room for us, Santosh. He also went to work for a social company. The one thing that you do is that when you shard, you lose some things. One thing that you lose is the ability to do ACID transactions. Because now your database is split into multiple parts. You write something that affects more than one database, you may have transaction issues. We had to rewrite our application to handle that. You can't do joins as freely as you used to before. And the client, over time, slowly has become more complex. Like the previous slide, you saw that the client had to figure out whether to send reads to a replica or a master. Now you have a client tries to figure out, based on the value of the where clause, whether which shard it should go to, based on the name of the table, which database to go to. And then there is actually a third complexity, which is the cross-shard index. There are some queries that don't shard well, which means that the key for the query is, goes across shards. So for such things, you create a cross-shard index, and then the client has to keep that up to date. So at this point, we have a really, really fat client. But then if you get here, you can go for actually many years with this. You can keep going until that word gets mentioned. It's called disaster recovery. So if you are in a company, you are in a situation where they are talking about disaster recovery, it's a very good time to make your resume. Because the stuff is about to hit the fan. So the way you handle disaster recovery is you basically replicate your data across data centers into multiple cells. And so this is kind of what it looks like, but way more complicated. You have a lot more verticals and a lot more horizontal. By this time, we probably have like 1,000, 2,000, depending on how big your database gets. You probably have 1,000 servers or so. And imagine each of these servers was manually built by a person. You cannot do that anymore with these many servers. And sometimes, but there are some things that improve. Like, for example, when you build data centers, for example, you can say, I'll build a data center in Japan, which means that Japan customers would have low latency because the data is right there for them. So there are some benefits to doing this, but it's mostly painful, mostly problems. And sometimes, like, we have had issues where somebody brings up a replica and then points it to the wrong master. Sometimes replicas, when you do a failover, replicas get ahead of the master. You get like alternate futures. You get parallel universes. There was once when we had to call upon Doctor Who the doctor to fix our space-time continuum issues. So, and then at this point, further resharding is pretty much like out of the question. You cannot manually reshard once you've done this. The problem is just too complex. But it just doesn't stop here. Like right around this time, what happened is that the number of engineers in YouTube grew to like a few hundred. And what do a few hundred engineers do? They write queries. And what happens when a few hundred engineers write queries? Every once in a while, each engineer messes up only like once a year. But you do the math and see what happens. Every couple of weeks, database will go down. Some toxic query would just do a full table scan, or it'll be an index scan, but the index would have like 1 million elements. So you would think, oh, who would upload more than 25 videos? Yeah. So Vitess, basically what it does is, this was in 2010. There's two of us, my good friend Mike, he's actually in the audience here, and myself, we said, we are completely in this reactive mode, and we are completely on the receiving end of things. We need to do something to leap ahead of all these problems, where we get on top of the problems and we stay ahead of it. So we kind of took time off. And we didn't take time off. We actually took ourselves out of the mainstream YouTube operational and scalability work and started building this Vitess. And our idea was to take it from point A to close to point B, somewhere close, which means that what we wanted to restore was, we wanted to restore the YouTube app to a point where it thinks that it's just interacting with one database, to basically get to as close as possible. So if you look at it, there are a few problems here that we are trying to solve. One is taking control of all the servers, keeping track of all the servers, what are the masters, who is related to who, and keeping all those relationships. The other one is the abstraction layer that helps you view this entire thing as a single database or a single data store. And the third one, which is that purple problem that cropped up, is how do we protect ourselves from bad queries? So those are the three components that I mentioned. One is the workflow management. The way we decided to solve that is to actually use a log server. We are using Zookeeper, and I don't have to explain what a log server is. Zookeeper is in the open source project, and internally at Google we use obviously Chubby. So Vitess is actually nicely componentized. We have a beautiful abstraction layer. If you don't like Zookeeper, you can throw it away and bring in something else like etcd. We are even thinking of a file-based workflow management system, because if your installation is small, you don't really need a log server. Like, if you can write to a file system and send that file system across to your as configs, those are good enough also. So that is the workflow management part. There's actually a workflow server that maintains this data, which means that when you do stuff like reparenting or bringing up replicas or bringing them down, there's the server that does that work for you. I'll talk more about that. And there are some command line tools which are meant for automation tasks where you can actually write scripts to do maintenance work. And on the server side, there is the VT tablet, which is actually a proxy that sits in front of every MySQL instance. I will talk about that. And the query router, VTGate, which gives you the abstraction to Vitess. Oh, looks like there's some font issue. So the log server, what information do we store in the log server? There are actually two log servers. One is the global one, and the other one is the local one. So the global one is central information for all servers to share. We store key space information. What is a key space? A key space is basically a logical sharded database. Since the name database is already taken, we had to invent a new name, and we called it a key space. So it's basically a logical database that represents a group of database, and you access them as one unit. We store information about the shard graph, which means that we do range-based sharding, which means that all these ranges and which database they map to, that information is in the global log server. There is also the list of master databases that are currently accepting write traffic. And there's the list of data centers where all this information is going. And in each data center, we have information about which are the replicas, what categories they are. Because once you're serving a lot of traffic, you need to, there are like specialized servers. There are some servers that you use for OLTP, some servers that you use for MapReduce. So we have lots of separations in Vitess. I may not have time to go into those details, but they exist. Vitess can help you configure those things. And also which servers are up, ready to accept traffic, and which servers are undergoing maintenance. Maybe some of them are doing backup, and all those things. So our goal is to basically automate things that would otherwise take a lot of time to do. Like, for example, when you decide to reparent. Typically, I don't know how many of you have done reparent, but at YouTube, reparent happens right now in about 30 seconds. You say, oh, this master is bad, we need to reparent. We issue a reparent command in 30 seconds, we have the new master up and running. We actually are experimenting with a 5-second reparent. I'll let you know how that goes when we try it on live. What else? Like another goal is to actually basically automated sharding, which means that right now we have n shards, and suddenly we are running out of capacity. We say, OK, let's shard it 4x. So you should be able to just go in and issue a command saying that, OK, split this into, we have 16 shards, split it into 64 shards. You issue the command. Ideally, it says, OK, I'm doing all the work needed, come back tomorrow and check on me. And then you come back tomorrow, and it says, oh, your shards are all ready. Are you ready to make the switch? And you say, yes, make the switch. It stops the masters on the 16 shards, brings up the master on the 64 shards, and now you're fully sharded. So we are very, very close. Actually, we are performing this operation. We are canarying this operation at YouTube as we speak. So we are very confident and excited about all these features. So like, this is kind of what the big picture Vitess looks like. You have the log server. We have the VTC TLD, which is actually the D stands for daemon, which is actually an HTTP server. You can basically go to VTC TLD. It gives you a full list of your entire list of servers, what's related to who, and then you can navigate that. And then you can issue commands about, OK, do a reparent, do a reshard, and there's like a whole bunch of common maintenance operations that we perform. And we use this for YouTube even right now. And the VTCTL is actually a command line tool that we plan to use for scripting. And on this side, we have the application. The application will talk to VTGate. We'll just send a query to VTGate, and VTGate will figure out where to route that query based on what type of query it is. So all these tools have SQL parsers, so they can kind of understand your query and know what to do with them. And eventually, VTGate sends a query to VTtablet, and VTtablet sends it to MySQL. And you may wonder, why VTtablet? What does VTtablet do? Why can't you just send the query to MySQL? VTtablet takes the query from the app and gives it to MySQL. But that's not all it does, obviously. So the first reason why we wrote VTtablet was the cost of a MySQL connection is huge. It's approximately about 2 megabytes per connection. And at YouTube, we have tens of thousands of connections. I think we have, last I looked at it, we had like 60,000 connections. That kind of, if you have 60,000 connections going into MySQL, it's guaranteed to die. Our MySQL started dying at like 5,000 connections. So that's actually when we launched VTtablet. So that was the first problem we solved. The other thing is that you remember the developers I talked about? It's for them. So if they write a bad query, how do you detect it? How do you handle it? So the problem with MySQL is that it is bound to the relational contract, which means that if it thinks that it can answer a query, it will do whatever it takes to answer that query at the cost of all other queries. So if you send a few queries that do full table scans, all your other queries are going to suffer, and it's going to bring the entire database down. And so how do we protect ourselves from even MySQL? Right? When you send all these tough queries to MySQL, it's going to cause site issues. So VTtablet basically is a mediator. It looks at every one of your queries and makes a decision about what to do with it. And I'll talk in detail about like, for example, if there's a query that comes in, it says, you don't have a limit clause here. Do you know how many rows this is going to return? So VTtablet puts a limit clause and then looks at how many rows it has returned, and it says it's more than what you should be fetching. So it returns an error saying that you're not allowed to run this query. So stuff like that. If a query really, really causes problems, we can blacklist it. And I don't know how many of you have struggled with MySQL. MySQL runs fine, and every once in a while, it starts to slow down, and you have no idea why. The only tool you have, you log into MySQL and do show process list. And then it tells you these queries are running. If you're lucky, you may find the problematic query and do something about it. But it's kind of shoot in the dark situation. And VTtablet will help you in those areas also. So the VTtablet also does other things. Apart from the query service, it also does tablet management work. Like if, for example, you want to initiate a backup, the VTtablet is the one that actually does the backup for you. And the other thing that VTtablet does is we are living in a very heterogeneous world where no single tool is enough for everything. Sometimes you want to export the data from MySQL into Hadoop or Bigtable and want to run MapReduces on those things. So what VTtablet gives you is a subscription service where you can say, give me all the updates that are going into MySQL, and I will use those updates to update a different database and then use that to run other analysis. So it provides all these streaming services. So this is a deep dive. I'll skip some of these items. Like I've already talked about connection pooling. The awesome thing about connection pooling is now we fail over a master at YouTube, and as soon as the master comes up, all the web servers that have been throwing errors, front-end 500s, just flood VTtablet, and then within a few seconds, no problem. VTtablet has accepted all the connections and is now serving queries at full stream, no thundering herd issue. So that's actually thanks to the Go runtime, because they've written such a good network stack. The there is this results reuse. This is actually a very common problem you will see with web services, is that one particular item or one particular user suddenly becomes extremely popular. Maybe because they are in the home page and or their Twitter is trending, whatever. And what happens is that when that happens, all the front ends end up sending the same query to the same row or to the same set of rows to MySQL. And if you actually directly send those things to MySQL, MySQL will actually independently execute each one of them. It has no idea that there are like 5,000 pending requests of the same exact query. So what VD-Tablet does is, if it receives a query and that query is already executing, it just holds off on it. And when the first query returns, it actually returns that same result to all the people who asked for that information. This used to actually be a big problem at YouTube, and we have never heard of that problem ever since we launched this feature inside VD-Tablet. We also have a SQL parser, which means that we can understand queries, and not only currently we do smart things about it. If in the future we see things that we need to do about these queries, we can do because we fully understand the query. But it's not the full MySQL syntax query, which means that there is a trade-off here. We don't allow anything and everything, but we allow pretty much most of the common queries. Just to give you a contrast, the Vitess query parser is about 1,000 lines of code, and the MySQL parser is 15,000 lines of code. But it's a very judicious heuristic approximation of what MySQL does, because almost every query that you commonly send to MySQL will work with VD-Tablet. So row cache, that is something I would like to talk about because everyone has been talking about caches the entire day today. So I need to do a sales pitch of what the awesome stuff that we did with our row cache. So before going into row cache, I need to talk about a problem that exists with MySQL. So MySQL has this thing called the buffer cache, which basically reads 16K blocks at a time. So if you have like 25 rows in a 16K block and you access one row, that entire block gets into the buffer cache. So that is actually fine if you're doing a full table scan because, everything comes to cache, then you also fetch the rest of the rows from the cache. But a typical online app, that's not the usual pattern. The usual pattern is random access. You fetch one row here, you fetch one row there, and what you're doing effectively is trashing the buffer cache if you're using that kind of access. And so what we decided to do, and the way actually that's actually the reason why Memcache exists. If MySQL was actually efficient about this, there's probably no need for Memcache. Anyway, that's a different subject. So what we decided to do was, Vitess has its own row cache, which is actually just Memcache. And what it does is, when you do a select, and if it's a primary key fetch, Vitess loads that row into the row cache, and all subsequent reads are served out of that. That's no rocket science. We all do that. But it does a few other smart things that usually a typical caching system doesn't do. One is, if you send an update, it invalidates it. But what if you're on a replica? If you're on a replica, there are no updates. There's only read traffic. What Vitess does is it actually subscribes to its own MySQL server as a replica and actually looks at the stream and uses that to invalidate the row cache. So what that means is that a typical cache is actually kept up to date through expiry. You say, okay, I can tolerate about 1 hour of staleness, so I'll set expiry. Whereas, but in Vitess, the row cache never expires because it's always up to date. So it's primary key-based fetches. It is consistent. And there are a few other things that Vitess can do smart, which is, for example, let's say you just sent a query, and then that query is not a primary key fetch. It's actually an index lookup. So Vitess analyzes your query. It knows the schema. It says, MySQL is going to do an index scan on this. So then what it does is it rewrites the query. It actually does only an index scan from an index table, and then fetches all the primary keys, and then goes to the row cache and says, okay, which of these do you already have in the row cache? Gets those, and what is left over is all it sends to MySQL. So if that same query comes back, pretty much your row cache is fully primed. The only thing that you end up doing is the index scan, and then followed by a row cache fetch, which is then returned back to MySQL. So these are like some things that we are very excited about. It is challenging to keep it up to date because you have to handle race conditions. Like, let's say I go to the row cache, the item is not there. I go fetch it from the database and try to write it to the row cache. What if the row has changed in the middle? Right? So there are a few flows that we have to take care of. We believe we have taken care of them well. We actually have prototyped this in a sanity check mode, and we have had weeks and weeks of run, and there has been no inconsistency with this. So we are actually getting ready to turn this on for full traffic. So that's one part we are excited about. And there are other fail-safes. So these are all features that are meant to protect ourselves when a bad query hits the database. Sometimes people will start transactions, and then we'll make some long-running RPC calls, and these transactions remain open for a long time. So Vitess actually tracks all these things and then tells you, oh, this transaction is being open for too long, I'm going to kill it. Same thing with queries. If query runs for too long, it kills it. There is actually, it limits the maximum number of transactions you are allowed to do at a time, because MySQL is not, becomes very, very unhappy when the number of transactions hits 1024. Ever since we did these things, all those problems have gone away. Query blacklisting is actually, strangely, we have put in so many defenses that we haven't had to actually blacklist a query yet, but the day will come. But the feature is there. And the DML annotations is actually for the binlog stream. I'll skip that. Stats is actually another awesome feature. Our SREs love this, because when there is an issue, you look at the graph, you almost always can figure out what's messing up, because we have roll-ups by query, by table. So the way Vitess accepts queries is it accepts, it's not like a full MySQL query. It's actually a rolled-up query where you have bind variables and stuff. So it actually groups stats for each of those unique queries, which means that if a particular query starts to go badly, it will show up in VT Tablet's list of badly performing queries. And that information is also rolled up into tables. So if a particular table becomes hot, it will immediately show up in the graphs. And this is something that we use on a daily basis and has helped us. Like, for example, there was once a time when the master latency just suddenly shot up. It used to be only like 3 or 4 milliseconds, and suddenly it's like 50 milliseconds. And like, people are panicking, what do we do about it? So we bring up the per table graph, and what we found out was it was just one query on one table that was just taking 10 seconds, low QPS. But then the average looks really, really bad. So we look at, okay, no need to panic. We just go talk to the developer and get that fixed. And so, and at the worst case, even if those stats don't help, we have something called the verbose stream log, which basically says you just hit VT Tablet on an HTTP server and stream every query that's executing. It tells you how long it took, whether it served any errors, what plan it performed, how many rows it returned. All that stat is available for you to troubleshoot. All right, so this I am going to skip because it's kind of a summary of all the stuff that I've explained, but it kind of shows how all the different VT Tablet pieces work together. So VTGate actually is also very easy to explain. What it does is query routing, which means that you just send a query to VTGate, it figures out how and where it should send. It's actually not that as easy to write, but it's a very critical piece of Vitess. Basically, this is actually the icing on Vitess's cake, because with VTGate, then your application has the opportunity to be restored to its original database agnostic glory. It's not done yet. It's actually the last feature that will make Vitess more or less feature complete. once this is done, then you can really, really use Vitess. That doesn't mean that you can't use it now. It's just that it'll make it a lot better as a story. So yes, Vitess is production ready. It runs really, really well. You just had to have wheels. It's served YouTube traffic since 2011. Like I mentioned, we currently, one of our higher QPS servers can accept up to 60,000 connections. Actually, it does accept 60,000 connections. We believe it can accept an order of magnitude higher than this. We just haven't tested it. Big increase in MySQL serving capacity, and all the stats and monitoring is something that our SREs love, and the row cache is getting to launch. Ironically, I said the same thing about 2 years ago about the row cache getting ready to launch, but this time it's for real. So yes, Vitess is written in Go. Many of you have not even heard of Go. How can you do something crazy like this? Yes, when we started launching writing Vitess in Go, we had lots of doubts. Not anymore. We are really very excited about it. It's not a toy anymore. This graph actually shows Go's adoption. It's on the rise and trending up. And we are very productive and very excited about it. This is actually somewhat of a techno-marketing slide. It talks about where Vitess stands. Basically, what Vitess did was it ditched relational databases, but didn't go all the way to NoSQL. Basically, what that means is that you don't get everything that you get with NoSQL databases, but you get other stuff that are good about relational databases, like indexes, joins. You do get some transaction facilities that you don't have at all in NoSQL databases. And we are excited. Hot off the press, just last week, we managed to make Vitess work with MariaDB. And we also made it easier to install. I don't know how many of you have tried to download Vitess in the past. It's a nightmare. You can't get it to build. Only 5 of us in this world could build Vitess, and they all work at YouTube. But now you should be able to download and build it. The main reason was because it also required you to download Google's version of MySQL and build it, and that's not easy. Not just Google versions of MySQL. It also required you to build libSSL, the right version of libSSL. Forget it. So all that has been removed. So if you can today download Vitess and build it, it's a pure Go binary. And you download MariaDB independently and build it, and we got it working against it. So you're welcome to try it. So that's the reason why it's easier to install. We are very, very close to doing MySQL 5.6. And after I heard the news today, I'm excited that we are also going to be doing WebScale, because the big showstopper was the GTID, and I just heard an announcement that they are going to support GTID very soon. So that's exciting. We are getting serious about releasing this as a Docker component, which should make it even easier for you to download and use. We are behind on documentation, but we are getting there. And we are also getting excited about cloud support and supporting other log servers like etcd, etc. We have some crazy ideas. So these may or may not work, but we think that if we pull these off, we'll make the system really, really, really awesome. So P2P replication. What is P2P replication? It's actually combining replication with peer-to-peer. So with all this GTID and stuff, a replica doesn't really have to be tied to a master, right? The only thing that the replica needs to know is where is my next transaction? I don't care where it's coming from. Anybody that has it can give it to me, right? So we are thinking that by infusing a little bit of the peer-to-peer protocol, we can basically free up all the slaves and say, well, slaves, this is your database, and you start with this GTID, and then you go fish for your next transaction. Ask anyone. If anyone gives it to you, take it, apply it, and go look for the next one. So what that should give us is actually zero config, which means that when you bring up a replica, you don't really have to say, point it to a master, point it to this, point it to that. A replica, by its very nature, knows what it is and should be able to go find the stream that it is looking for. Typically, we expect that it'll find one source to replicate from and stay with it, but if that source goes away, it'll itself find the next source and replicate from that. So, so which means that a whole bunch of maintenance tasks will go away. It's all crazy ideas. It may or may not work, but I think if we make it work, it'll be awesome. The other stuff is Paxos. There's been a lot of research on Paxos, and typically, a Paxos transaction completes in like 100 milliseconds, the long tail latency. But 100 milliseconds for a normal transaction is very expensive. But what if we used Paxos for MySQL to elect a new master? Which means that MySQL should be like, if a master goes down, MySQL should be able to elect a new master within 100 milliseconds. Right? So the 5 seconds we were talking about before now looks like an eternity. And if you combine Paxos with P2P replication, it's pretty much zero config, which means that if a quorum of MySQL servers decide that a new master is now, they elect a new master, all the replicas will automatically find the new master and start replication from that point, which, so I think those two features will marry well. The parallel replication is something we are excited about, but I don't know whether it is going to keep up with all the new features that MySQL has. The reason why we think we can do better replication than MySQL is because we are a sharded database. We know the key space IDs that are changing, which means that we know we can, by looking at the transactions, we already know what is isolated and what is not. And we think that we can actually replicate very quickly, run as many threads as we can in order to replay replication. So we'll probably explore this if we think that the newer versions of MySQL can't keep up on replication. And there's other stuff which means that, like, since we have this query log stream, we think that we can just dump it on a MapReduce backend and then run analysis and stuff. And this per row data protection with all this new stuff that's coming about authorization, snooping, and all these issues, there are actually schemes where you can say that only a user that is logged in, they will have a cookie, and that cookie is the only thing that can be used to unlock a particular row, which means that only a user, it's an end-to-end guarantee that only a user is allowed to see their data. So if accidentally another user comes in, their cookie will not be able to unlock the data of another user, which means that there is actually a low-level protection from people, from data getting cross-linked or even unauthorized access to data. So I think this is going to become very important in the coming few years, and we are actually seriously looking at doing that. All right, the team. Actually, it used to be just 2 of us. Now we are actually a full team. We are 6 SWEs. Our TL is Alain Choubard, who is not here. Our SRE TL is Brad. Actually, he's right here. Actually, maybe you should have, I'm going to put you on the spot. We should have all the Vitess people stand up and wave. Yeah, there you go. All right, there's Mike, there's Brad, there's Adam. There's a few others who are shy. Oh, there you go. There they are. So that's about all I have to say. Wow, perfect timing. That's good. If you have any questions.
Yes, Raghu.
Thank you.
So definitely very exciting project. So the questions, I think several questions came to my mind. I'll limit it to one. So the VT server, it has metadata, hopefully, about all the data structures and all that. So do you do DDLs, alter tables, and all at the, bypassing your VT server, or are we going through the whole Vitess?
We do. At YouTube, we actually bypass it, and we have safeguards around that. But actually, what we are actually retooling those to actually go through Vitess, which means that when a DDL hits, like there are things that we have to react to, like when a DDL hits, when a table changes, we have to invalidate the row cache. We have to, we also have a, that is something I didn't talk about. We have a schema rollout plan where sometimes you just apply the schema. Sometimes you have to play the shell game where you go apply the schema to a replica and then make that the master, and then you go apply the schema to other places so that you can keep uptime, especially for busy tables. Yes, Vitess does allow DDLs. That's the short, yeah. Anything else? So let's go party? Yes.
All right, thank you again, everyone, for joining us today. We heard a lot of terrific talks, both in the data track and on the web and mobile track. So a bunch of people came up and asked about slides and videos from the talks. We will be posting videos on YouTube and sharing them on the Facebook group. So if you're interested, please go subscribe to the Facebook group and you'll get the videos. We already have the first couple of them on the group. And we hope that today is the beginning of a conversation among all of us on how best we scale and how we can learn from each other. With that, I don't want to hold anyone from the happy hour. Happy hour is on one floor up, and you can grab your T-shirts on the way out. Thank you.